Hello all, I am Dr. Prabhas Chanjanbal. In today's class, we'll discuss about the problems that are related to Rice theorem for undecidability. Okay, just say what is the problem? What first thing? First, we'll discuss about the Rice theorem. What is the meaning of Rice theorem? We have already discussed some problems and what is the meaning of Rice theorem in the previous classes. Okay, again, I'll discuss a little bit about the Rice theorem. What is the meaning of Rice theorem? Rice theorem is what? Any non-trivial property of a real language means recursive enumerable language is what? Undecidable. Okay, this is called as what? Rice theorem. Any non-trivial property of a real means recursive enumerable language is undecidable. Okay, so this is very important. What? Now here we just find out what? Non-trivial property of a real language. Non-trivial property of a real language. But we cannot apply on what? We cannot apply on Turing machine and type 0 grammar. We cannot apply this non-trivial property means this Rice theorem on what? Turing machine and type 0 grammar. Okay, so we cannot apply on Turing machine, we cannot apply on type 0 grammar. We cannot apply means we cannot apply Rice theorem on Turing machine and type 0 grammar. We have already discussed in the first class, means first class of Rice theorem. Okay, so we'll only apply on what? Recursive means a real language. Will only apply on means will only means Rice theorem on a real language. Okay, so this is very important. Now we'll see. The first problem is what? Does the given Turing machine accept what? Regular language. Does the given Turing machine accept regular language? First, one important point. First we have to check, can we apply the Rice theorem on this problem? Can we apply the Rice theorem on this problem? After that, we'll check what? This may be trivial property, this may be non-trivial property. After that, we'll check this problem is undecidable or not. This is after that. But first we have to check what? Can we apply the Rice theorem on this problem? This is important. Okay, now we'll see. What? Does the given Turing machine accept regular language? What? Rice theorem said that what? Any non-trivial property of a real language is undecidable. It cannot be applied on what? It cannot be applied on Turing machine as well as what? Type 0 grammar. But it talks about what? Turing machine. That means we cannot apply the Rice theorem on this problem. No, we can apply the Rice theorem on this problem. But how? This is very important. What? Does the given Turing machine, just say, does the given Turing machine accept regular language? Does the given Turing machine accept regular language? Okay, just say. Generally, Turing machine accept which language? In generally, Turing machine accept which language? In generally, this is Turing machine accept a real language. Generally, Turing machine accept a real language. So just say. Now we'll just read. Does the given Arial regular language? Now we'll read what? Does the given Arial regular language? It's just like the previous question we have already in the immediate previous class. Just say. So does the given Arial regular language? Yeah, of course. May or may not be. Sorry. Now we'll apply. Now we'll check. Can we apply the Rice theorem? Okay, we'll see. This is the domain. This is the range. Range contains 0, 1. Domain means what? Set of Arial like L1, L2, L3 up to L infinity. Okay. So now here I have just converted. I have converted this question into what? Does the given Arial regular language? Yeah, of course. Some of the languages may be regular, but some of the languages may map with 0. So this is called as what? Non-trivial property of a real language. This is called a non-trivial property of a real language. Non-trivial property of a real language means this problem is what? Undecidable. Okay. So this is called as indirect question. This is called as what? Indirect question of Rice theorem. Indirect question of Rice theorem. This is very, very important. So when we are talking about what theorem accept regular language, so which type of problem means we cannot apply means Rice theorem? Just see this problem. Just see the second problem. Does the Turing machine have 10 states? So now, can we convert this Turing machine? Here we convert the Turing machine into RL. Here we just convert the Turing machine into RL. But can we convert this Turing machine into any? There is any chance to convert RL language? Can we convert? Is there any relation between Turing machine and RL language here? But here, yes, there is a relation between Turing machine and RL language. Because just read the problem. Does the given Turing machine accept regular language? So Turing machine accept which type of language? RL language, yeah, of course. So does the given RL regular language? Okay, now we'll convert this one into RL language. But here there is no chance. There is no chance to convert this Turing machine into RL language because this problem is completely different. There is no link or there is no relation between Turing machine and RL language here. Does the Turing machine have 10 states? There is no relation. There is no relation. So we cannot apply Rice theorem here. We cannot apply a Rice theorem. We cannot apply a Rice theorem on this problem. This problem may be decidable, may be undecidable, we don't know. But first thing, we cannot apply Rice theorem. Okay. After that, after applying the Rice theorem, okay, then we'll decide this problem, the given problem is decidable or undecidable. But here we cannot apply the Rice theorem. Okay. Just read first and second. Just read the first and second problem. First problem, we can convert this problem into RL language. Means, does the given Turing machine accept regular language? That means Turing machine accepts generally regular language. But here there is no relation. That means this sentence, we can say this sentence, there is no relation. There is no relation between the RL language with the RL language. Okay. Now we'll see one more problem. The third problem, just say, does the given Turing machine compute addition and subtraction? There is here we cannot convert this Turing machine. Here we cannot convert this Turing machine into RL. No, there is no chance. There is no chance. Does the given Turing machine compute addition and subtraction? There is no relation. There is no relation between the Turing machine and recursive enumerable language. So that's why we cannot apply Rice theorem on the third problem. We cannot apply Rice theorem on this problem. Okay. Now we'll see one more problem. Does the given Turing machine accept finite language? Just say, does the given Turing machine generally accept which type of language? RL language. Okay. So does the given RL finite language? Okay. Now we'll see. This is the range. Range means 0, 1. Domain means what? Set of RL. Domain means set of RL. Set of RL means sum of the language L1, L2, L3 up to L infinity. So does the given RL finite language? Yeah, of course, some of the languages may be finite, some of the languages may not. So that will map with 0. This is called as what? Non-trivial property of RL language. Since it is the non-trivial property of real language, so this problem is what? Undecidable. Okay. Now we'll check one more problem. Does the given Turing machine accept string of length 2023? Just say, does the given Turing machine accept generally which type of language? Real language. Turing machine accept generally real language. Just read the problem again. Does the given real contains any string of length 2023? Yeah. Now we'll design the property. This is called as what? Set of real. Set of real means it can L1, L2, L3 up to L infinity. Range contains 0, 1. Some of the languages may contain the string of length 2023, but some may not. That means it will map with 0. So this is called as what? Non-trivial property of real. So this is called as what? Non-trivial property of real. Non-trivial property of real means, so this problem is what? Undecidable. Okay. So in the next class we'll discuss some different types of problems that are related to Rice theorem. Okay. Thanks for watching.